Built on 25 years of learning sciences and math education research, SunBay Math is a curriculum of replacement units for middle school's most difficult math concepts.
Personally, my experience with SunBay has been really positive. I've enjoyed watching aha moments, probably at an exponential level compared to textbook pages.
I make my students think a lot more instead of just feeding them information, which is what I feel like I was doing before now.
There are 3 core features of SunBay Math. First, an inquiry-based approach that emphasizes collaboration and conversation and is aligned with the math practice standards. Second, technology activities where students manipulate mathematical objects and explore their reasoning in real time. And third, a pedagogical routine that leads to conceptual understanding and robust mathematical discourse. A typical SunBay day consists of 3 parts: a brief warm-up, the main section where students predict, check, and explain, and a wrap-up that brings it all together.
On the screen, I usually have the investigation that we're starting with, and they can begin the warm-up without me because it's something that they should be able to do currently on their own.
During the main portion, the teacher introduces the class to the day's challenge.
The strategy is predict, check, and explain.
Students will use their intuition and past experience to predict a solution to the problem.
The predict part, that's the best part, because it's like, what do you think? And they're going to tell you what they think.
I can let go a little bit, become the observer on the side, let them talk about it, and even if their conversations aren't necessarily the most accurate or the correct answer, it's still a conversation that's allowing them to work on a path.
In small groups, students turn to an interactive simulation to check their prediction. They learn from the simulation whether their prediction was accurate and adjust their thinking in real time. The Predict, Check, Explain cycle culminates in students' conversations about math. They talk about what they thought would happen, describe what actually happened in the simulation, and explain any discrepancies.
They explain, how do you know this is a rotation? How do you know that this is a reflection? And if they see visually through the checking process that it makes no sense, and through the explanation process, then they're more apt to go back and check it and correct it.
When students put their observations into language, they find analogies and frameworks that make sense to them.
I like that they get to think about mathematics, predict why something would be happening, and then to check using technology, and then they can actually explain the mathematics to themselves better and to me better, and I think it gets to the understanding level a lot deeper.
I think it's important to have the wrap up or any of those questions, bring it back together and discuss it as a whole class, just to make sure that if there's any groups that I didn't get to, that everybody's on the same page and everybody understands.
Teachers find many benefits to using SunBay in their classrooms.
Would be after teaching the unit on a particular ratio standard, giving the assessment where some of the questions were SunBay related and some of them were completely non-SunBay related, they were still successful in both types of questions that they were able to translate it over.
One of the big changes I've seen from my students is the willingness to answer why or how. Now when they're helping each other, it's more collaborative rather than here's my answer, copy it, and let's call it a day.
I've incorporated SunBay's techniques into all my classes. So my algebra class, my 7th grade classes, they all have benefited from what SunBay has done.
I love the software, I love the curriculum, and it will definitely change your class, definitely.
To learn more about SunBay Math, visit sunbaymath.org.